Welcome to the very end of chapter 2. We are finishing off with an application of derivatives for demand, elasticity of demand. So we're going to start this video by talking about what is elasticity of demand. But I'm going to sneak it in there, okay? So let's just forget about the word elasticity for a second, and let's look at a problem. So suppose that we want to maximize the revenue of selling Q items at P dollars each, so we have some demand function. So again, remember that revenue is just price times quantity, and a lot of times we use our demand function to get a revenue equation with only one variable. The letter A is saying find R prime of 40. So find the marginal revenue when we're producing 40 items. So we are going to need that revenue function. Again, hopefully this is pretty comfortable right now. Revenue is P times Q. And what is P? P is 100 minus Q because of our demand function. So this is our revenue. And if we distribute, like we've done many, many times before now, we should get our revenue function pretty easily. Again, if this is uncomfortable for you or a little confusing, that's fine too. Just make sure to ask questions about it. But we've done this a few times by now. And we need to find the derivative. So we take the derivative using the power rule. We could write this as R prime, or we could be more official and write R prime of Q. And get 100 minus 2Q is our marginal revenue function. Now, we need to find out what happens when we plug in 40. And when we plug in 40, we're going to get, this becomes an 80. We're going to get 20 over here. In other words, at a production level of 40 items, each additional item will give us about 20 extra dollars. All right. Now, the question is, well, that was one of the parts of the question. Should we increase or decrease production? If we want to maximize revenue, there's a very easy answer to that. I'm saying easy too often here. But right, marginal revenue says that increasing production is going to give us an extra roughly $20 per item. So of course we want to increase production because increasing production is going to give us extra money. Yeah, we increase production, right? It's positive. Our revenue goes up if we increase production. Nothing new yet. What is this? No clue. Well, that's a lie. I do actually know what it is, but I'm going to pretend like I don't. Let's do part B. So now, at a production level of 60 items. Well, we already found the derivative, so don't need to do that again. Just plug in 60 here. And if you plug in 60 here, now you're going to get negative 20. Huh. So here, that means our marginal revenue is negative $20 per item. Increasing production at 60 items will mean we make 20 fewer dollars in revenue for every additional item we make. Well, if our revenue is going down for making more things, we should not make more things. In fact, we should go backwards. We should decrease production here. So what we have, right, is revenue is price times quantity. So you would think increasing production, increasing the quantity would increase our revenue. But the problem is the price also depends on how much we're producing. So sometimes the increase in quantity is worth it, is worth the decrease in price, right? Look at this demand equation. This demand equation says that if we want to sell more items, if Q is bigger, this is aligned with a negative slope. If Q is bigger, P has to be smaller. If we want to sell more items, we have to charge less. And so sometimes it's worth it. Sometimes we sell enough more items and that the decrease in price is still worth it. And sometimes, like in part B, the price decrease is too big and it's bad. Visually, we can see this on Desmos. Let's plot our revenue function. Revenue was essentially 100 minus Q times Q. All right, so let's just redo our axes a little bit. Okay. This is our revenue function. So at 40, the marginal revenue is positive. The slope of the revenue function was positive. We wanted to increase production. At 60, the marginal revenue was negative. The slope of this function was negative. We wanted to decrease production. Everything over here makes it, we want to increase production. Everything over here, we want to decrease production. The relationship, what I'm really trying to drive at, is what's the relationship between price and quantity? And that's what we're really going to talk about. This is sort of what is going into something called elasticity of demand. It's this idea that selling more items, right? Revenue is price times quantity. So increasing quantity should increase our revenue. But demand says that increasing quantity means we have to lower the price. So that's going to mean less revenue. Sometimes the price decrease won't be that big. Sometimes the price decrease will be that big. And the question we're answering in that section, this section, is what is more impactful when between quantity increasing and price decreasing? That's this concept of elasticity of demand. So we have this, let's again assume that we have some demand function. We're selling Q items at price P. Elasticity of demand is some equation. Let's not look at it too much just yet, but we can calculate that. It's just a derivative times a couple values. And it means that if the price increases by 1%, the demand will decrease by E%. Elasticity of demand is about normalizing the relationship between price increasing and demand decreasing. Because this is a fundamental rule of oh gosh, I don't know enough about economics to say the precise system. But in like a closed system or whatever, a monopoly. Yeah, in a monopoly, right? The idea is that, an increase in price will go to a decrease in demand and such like that. That's what we've been saying all quarter for these very simple economic systems. And this is how we can kind of measure it. When I say we're normalizing this, we're talking about percent increases and percent decreases. Okay, because it doesn't matter whether it increases by $5. What it matters is what percent it's increasing here, so that we don't really have to, it makes the calculations a little simpler. So look at this. Again, forget about the formula for a second. Look at this definition. If the price increases by 1%, the demand will increase by E%. That's what elasticity of demand means. So look at what we can do with it. What happens in this case? This first bullet point, if E is less than 1. If E is less than 1, that says, let's pick a number. Maybe we're at E is 1/2. Let's say if E is 1/2, what does it look like? Because a half is less than 1. Well, that means that if the price increases by 1%, the demand will decrease by 0.5%. So what's changing faster? Price is increasing by 1%, demand decreasing. What's changing faster? The price is changing faster. The increased price is growing faster than the decrease in demand. So that means that we want to increase the price. Why? Because revenue is always price times quantity, but increasing one will always decrease the other. So it's just a question of what's increasing or decreasing faster. If the increase is faster, then we want to increase it. If the decrease is faster, then we want to decrease it. So here, if E is less than 1, the word that we say is demand is inelastic. And that looks like price is increasing faster than demand is decreasing. So in this case, we want to increase price. So increasing price increases revenue. And likewise, if E is greater than 1, let's say E is 2, for example, then increasing price by 1% decreases demand by 2%. That's bad, right? That means price is only going up by a little, but demand's going down by more. So increasing price is going to be bad for us then, right? Decreases revenue there. So just think about these example letters. And then if E is 1, that means a price increase of 1%, means a demand decrease of 1%, which doesn't really do anything. That's going to be a unitary demand. And it essentially means we're at a critical point of the revenue function. So this is kind of a complicated concept. I actually remember the first time I was learning about this a few years ago. And it's not super easy. So just think about it a little bit. Ask me some questions. We'll do some more examples, which will let us kind of explain these topics a little bit more as well. Also, yeah, don't hesitate. Ask questions. Have a good one. Bye-bye.